Welcome, everyone, to the Global Spaceport Alliance webinar series. I am James Corsi, its Executive Director. Now, before we get into the meat of the meeting, I would like to thank our sponsors. RS&H is our title sponsor, and our co-sponsors are BRPH and Merrick and Company. So thank you all for your continued support. A measure of the continuing success of GSA is that we continue to grow our membership. And we're very pleased that since our last meeting, we've added 2 new spaceport operations, the Peruvian Spaceport and the Main Space Grant Consortium. And in addition, we've added 2 new associate members, Mead and Hunt and Mitsubishi Corporation for Americas. While I have all of your attention, I would also like just to remind everyone about the Commercial Space Week taking place in 2024 in Orlando, Florida. It kicks off with the GSA Summit on January 29, runs into the U.S. Space Force's Space Mobility event on January 30, and is rounded out with SpaceCom on January 30 through February 1st. And now, in order to introduce our guest, I'd like to introduce you to George Neild, our chairman. And George, it's over to you.
Thank you, James, and welcome everyone. This is such an exciting time for commercial space right now. There's just so much going on, it's really hard to comprehend. Just since our last webinar at the end of last month, been quite a lot of activity. I wanted to just highlight just a few of the significant accomplishments and events. Back on May the 10th, a company that I had not heard of previously called VAST announced that in collaboration with SpaceX, they were planning to launch what could end up being the first commercial space station, which they call Haven 1, and that could take place as early as August of 2025. That would be followed a short time later by a launch of a Falcon 9 with Dragon, carrying 4 astronauts to that space station operation for a stay of up to 30 days. So looks like there's quite a bit of competition now for companies that are interested in taking over from the International Space Station after it completes its operations. On May the 13th, Stratolaunch had a successful separation and release test of their Talon A separation test vehicle from the Rock carrier aircraft out at Mojave. So congrats on that successful test. May the 19th, NASA announced that Blue Origin had been selected as the winner of the 2nd Artemis lunar lander contract. Of course, SpaceX had previously won an award, so now we have some competition for that. Very exciting. Congrats to Blue Origin. May 21st, we had the successful launch of Axiom 2, and then they just landed with a splashdown last night in what was the 2nd personal astronaut or private astronaut mission to the International Space Station. On May the 22nd, the Spaceport company conducted 4 sounding rocket launches from a platform out in the Gulf of Mexico. This is sort of a dry run for how their operations will eventually be taking place with larger systems in the future. So congrats to Tom Murata and his team at the Spaceport company. And then May 25th, Virgin Galactic conducted a successful suborbital spaceflight with Spaceship 2, and that went very well, and that means that hopefully as soon as the end of next month, they could begin their commercial operations at Virgin Galactic. So congratulations to all. And there's a lot of other things going on. Don't have time to mention all of those here, but it's just an exciting time to be in the business. Today, we've got a very special topic and a very special presenter. Khaki Rodway is our speaker for the day, and she is the Spaceplane Sales and Operations Director for the US for Dawn Aerospace, and her role involves bringing to market the Dawn Mk-II Aurora, which is a rocket-powered spaceplane for research, education, and commercial operations in the United States. I've known Khaki for a number of years. She's been involved in building new space companies and industry groups since 2005. In fact, she was one of the first hires at XCOR, a company many of you are familiar with, which designed and built the Easy Rocket, the world's first privately built and flown rocket-powered airplane, as well as the X-Racer and Lynx. As Director of Payload Sales and Operations, Khaki led all the marketing, sales, and operations for XCOR's research and education missions, managed their government contracts, and ran the global payload sales channel. She also co-founded New Space NYC, an open community for the development of private companies commercializing outer space. Khaki's published papers on suborbital space research, propulsion systems, composite materials, well logging science, remote sensing and archaeology and heritage conservation, and architecture and historic preservation. She got an MS degree from Columbia University School of Architecture, Planning, and Preservation, and a BA from Douglas College at Rutgers University. So it's a real treat to have you on today, Khaki. Congratulations, and I will turn the program over to you at this point.
Thank you, George. Thank you for that introduction. And thank you all for having me. It's a real honor and privilege to be here and to talk to you all today. So if we're ready, and Steve, I think you can give me the nod, but I think we are. I will share my screen and we will start this talk. I'm just going to tee it up from the beginning. It's always a good thing. And before I start, I'm not going to apologize, but I'm in New York City. It's noisy. If you need me to talk louder over the sirens or the construction that's out my other window, just let me know. But we will get going here, and so this is, presume everybody can see my screen. So today I'm going to talk to you about Dawn Aerospace. If you are unfamiliar with us, I'll give you a little briefing on us,
headphones on?
What we do.
Or do you want to hear about Dawn Aerospace? I hope so.
No, you're not.
So,
If everyone will,
mic there.
everyone will mute their mics.
So anyway, continuing on. So the Dawn Mk-II Aurora rocket-powered suborbital vehicle. So Dawn Aerospace, who we are, we're about 110 people. The interesting, and that keeps fluctuating because all year round we have interns, because what's nice about that is that we are in the Northern Hemisphere and the Southern Hemisphere. So we're in New Zealand, the Netherlands, and the US, which means we have interns all year round, because summer in the Southern Hemisphere is winter in the Northern and vice versa. So we have 57 thrusters in space. We've launched 10 launches every space or SpaceX transporter missions, 1 through 7, Soyuz, Vega. So we're very familiar with operations at spaceports and fueling and what we need to do to handle our customers there. On the Mk-II flights, we have 50 in total. So I'll get into that in a minute. And then we have customers. We have 15, little more. That plus is customers that we can't talk about, not because we don't want to, but mostly because they want to keep it quiet. What we are is a space transportation company that is scalable, sustainable, low cost space transportation. This is our vision. This is why we're in this business. So to develop this end-to-end transportation network. And I should say, you stop me at any time if you have any questions. How we got started. So our founders, 6 of whom are in this picture, so 6 of 8, were students at TU Delft, and they won the prize for highest rocket flight and decided they were going to explore the US and come out to Mojave Spaceport, Mojave Air and Spaceport, if Stu is listening. And they visited this company called XCOR and got really inspired by looking at the space planes that XCOR was developing. They said, we could do that. We want to do that. Need to finish our school first, but let's really think about that. And they all went off after they graduated, went off about a year. Some got their master's degrees, some worked in other companies, got back together and said, okay, how do we do this space plane? Well, the goal was to build this 22-meter, what we call Mk-III. So the idea was to build this 2-staged orbit. Again, it's a suborbital space plane, but it will launch small sats on the 2nd stage to orbit, LEO and GEO. But they also realized, as business people, they needed to make money. So they said, propulsion is our strong point. That's what we know the best. Let's build in-space propulsion systems, and started doing that. So started with these thrusters that you see here, the B1, the B20, and that designation is the Newton thrust level. So the 1 Newton thruster, 20 Newton thruster, those, I think we have more 20 Newton thrusters on orbit right now than we have the 1 Newton. The 200 is in development, but ideally it's a turnkey propulsion system. So we don't just sell the thrusters, we sell the entire systems, including the tanks. So basically what you see here in this image is what we provide to our customers. And, you know, again, scalable, sustainable, low cost, green propellant to that end. So getting back to one of my first slides, 57 of these thrusters on orbit. So we're making money. And this is where we're making money. We have customers, both government customers, commercial customers, and you see some here who are big companies, small companies. You know, again, a lot of the government organizations. We'll get NASA on there at some point in the very near future. But this is who we're working with. So back to space planes. So again, the Mk-III, the grand vision that we have. Again, from a business standpoint, there was not enough money to go in. They weren't billionaires to go in and build this big vehicle, the ultimate vehicle. So started small. I don't want to call it subscale. I want to call it small scale, but this is the Mk-II that you see down here. So compared to this, 22 meters, almost 5 meters. And this is where we are right now in development. And again, it is a plane. It is a rocket powered vehicle. So where we think of this is like an aircraft. And so the test development phase, the flight stage, is much like an airplane qualification. So, well, I don't know if it's similar, put it that way. Not quite much like. So we built the airframe. We built airframe, all the subsystems, put a jet engine on it, flew that 47 times. This is complete. This phase 1 is complete. We are now in phase 2, where we took the jet engine off, put a rocket engine on there, and we've flown that. And so we are in the qualification stage right now. We tested back in March. Right now it's winter, and we fly at the foothills of the Southern Alps. So weather's a bit iffy, and everybody's back in there developing the next phase of the vehicle, which will get us to the Kármán line and higher performance, some different subsystems with that too. So that's in critical design review. So we call this the Mk-II. And then again, the Mk-III. This is a ways out. This is at least 3 years out, probably 4 or 5. So while we're thinking about this, and in our qualification for Mk-II, we're going to do some demonstration of Mk-III flight profiles. We're not here quite yet. So again, what we have in the vehicles, we call this an uncrewed space vehicle. People have called it a drone, a UAS. It's, again, horizontal takeoff, horizontal landing. It's remote piloted. We need about 1,000-foot runway, so not a whole lot. And I'm specifically talking Mk-II here. We could do a parabolic trajectory, or we could do a customizable trajectory. We can get into that. But aircraft-like operations. So come down, we fly, we come down, we refuel, and we can fly again same day. So we could fly, ideally we want to fly a campaign. So somebody has a payload, they come to us, especially on technology development. It's like, let's get multiple flights in there and test out the instrument and fly every day if we have to. For some reason so these are the system elements. I'm not going to necessarily read them to you, but as you can see, we've put a lot of thought into it. And as you can see, there's a lot of aircraft-like systems in here. Obviously not like the reaction control systems or necessarily the power distribution but very similar again. And then we've thought about the ground systems. I mean, again, we've flown this, so we have to think about these things. So here's a video of the Mk-II phase 1. This is the jet-powered flight that we did 47 times. Just a summary.
Observers confirm no traffic. traffic be advised on my aerial vehicle down into land 115.
So these were the goals. We pretty much accomplished everything we set out to do in this campaign. It took us a while, so you know what? I'm just going to go right to the next one, because instead of showing you a static test of the rocket engine, I'm going to show you the synopsis of the rocket-powered flight. Again, this is same airframe. Jet engine is off. The rocket engine is on. Prior to this flight, we did tie-down tests of the integrated airframe with the rocket engine. This went to about 68,000 feet. First flights, though. So we were out there for 3 days.
4, 3,
We flew every day.
1. Head thrust.
So here's a summary of the specifications. This is on our website too. Actually, there's a bit more specs on the website if you go to this link down here. But I want to point out to you some of the payload specs, obviously, are quite interesting. It's a very unique vehicle in that it is a payload dedicated flight. So someone comes to us and says, we want to fly at 80 kilometers in altitude, and we don't want to do the parabolic trajectory, but we kind of want to come off and maybe do some loops or do some bends. We could do that. We could. I mean, certainly look at that and see how we do it. And we've with the flights that we've done, it's actually was. The three rocket powered flights that we did a number of flight paths on that. So we have this microgravity time. We can calculated that we can get to 100 kilometers in altitude, calculated up to at least up to Mach 3 in terms of our speed. And yeah, we can go into that. Anybody needs a little bit more info on the rocket engine, we can also talk about that. How do we differ from the others in this suborbital regime, this research technology development? Well, we're lower priced. Our altitude is comparable, certainly, to Blue Origin and Virgin Galactic. more than balloons, and not quite as high as sounding rockets. Our time is more than sounding rockets, more than New Shepard, but obviously not as long as Spaceship Two, and not as long as balloons. Trajectory, again, fully customizable. So someone comes to us and says, let's do X, let's do X. Again, small payload mass, same amount of microgravity time. Here's the big thing, is the time to flight and cadence. Someone wants to fly, as long as the vehicle is not tied up doing other things, we could fly within a month. We can also fly a couple times a day or multiple times during the week. So what we're looking at in terms of missions, Earth observation, microgravity, atmospheric measurements, that's going to be quite interesting, especially because if we can fly at multiple altitudes. And I should also mention that on the payload side of things, we can contain that payload in the bay, or we can open it to the atmosphere. So we can do in situ measurements. So technology development. The other thing that is quite interesting, besides the education, that's quite interesting, is the disaster response and recovery. And this is where we get into regional applications. So, for example, Spaceport in California, wildfires, New Mexico as well. Wildfires could, are going to be a cause of concern. We can go up, take some observations, do some monitoring quite rapidly, come back and then coordinate with the fire departments down, or Forest Service down on the ground, and we can do this in real time. Hurricanes on the East Coast, on islands. Lest you think what the videos that I just showed you were CGI. This is where we fly. You see Christchurch up here, Glen Tanner, also called Glen Tanner Aerodrome. This is Lake Pukaki down here. The Southern Alps down here. Mount Cook is right up here. South Island of New Zealand, obviously, but this is where we fly. So a lot of what you saw was the glacial action that is hopefully still going on a little bit down there. Where we could fly, horizontal launch, horizontal landing. We need 1,000-foot runway, and we can go. We need a little bit more than that, but we can talk. Scalable, sustainable, low cost. So Earth to space, space to everywhere else. Everywhere else. And that's it. That is all I have.
Fantastic. Thank you, Khaki. That's just incredible. You and I have talked a bunch about what could be done with a system like this. And I know it's early, but as you look at these kinds of capabilities, it seems like there's a huge potential for use in many different places. At the Global Spaceport Alliance, we like to think that, yes, that's true. There's not just one kind of spaceport. It's not just something that can only be done in a particular location. And all spaceports are different, with different capabilities, different interests, different objectives, different kinds of operations that they would like to host. It seems to me that a system like this would have huge potential for collaboration with a local community, if you will, of businesses, of academic institutions, getting students involved to see what space operations are all about, and potentially operating after developing and building their own CubeSat type experiments and so forth. Any preliminary thoughts on that type of an application?
Absolutely, George. Yeah, and there's multiple parts in what you just said, and certainly it is and applications can be a regional vehicle. So you have a suborbital vehicle, reusable suborbital vehicle that can be applied to multiple applications, even at the same location. So, and what we're seeing is each location is going to have its particular needs. And for education, absolutely. I mean, I've talked to numerous educators, numerous scientists who are eager to have this vehicle and use this vehicle. Imagine a space vehicle that say a university or research organization has at its disposal when it needs. So it could even be a consortium, or it could be a university by itself. But I mean, think about the universities and the oceanographic geoscience institutions that have their own ocean-going research vessel. This can be a space vehicle along those same lines. So again, it can suit the education needs. We've talked to students who are quite eager to build a CubeSat, put the instrument on that, develop that instrument, and then take that instrument even to a small sat. And for workforce development, you can't get any more comprehensive than something like that in terms of a student's career and a student tenure. So for the community, you're going to have locations that have, say, a strong agricultural economy, and because the vehicle is rapid and responsive, we can tune it to those development needs, those community needs. You want to monitor parks. Basically Earth observation and Earth monitoring can be a very big thing.
So you talked about the Mk-III as the end goal, and having the capability to actually have small satellites actually get into orbit and so forth. And I think you said that would probably be 3 years or possibly a little bit longer than that for that. It looks like, though, that at least the upgraded versions of the Mk-II could actually have the ability to do some of that demonstration or preliminary research at what we used to call the ignorosphere, higher than planes fly and lower than satellites fly. And I'm sure there's a lot of interest in that. any rough timelines of how soon you could actually be in operation with customers and so forth if you decide to use the Mark II for that type of thing?
Yeah, sure. So we could, all goes well, and obviously rocket engines can be fickle, and we know how some of that goes, but all goes well, we could start flying commercial customers early next year. And certainly get them to 20 kilometers. And then by end of next year, we could have them up to 100 kilometers. That's our goal. That's our objective. So if again, all things go well, we can start that process. And yeah, the ignorosphere, the atmospheric science measurement is just, I don't know. I'm really keen to start seeing some measurements there because it's well known, I think, that range, I guess anywhere from 40 to 100 kilometers in altitude is not measured. There's a lot of modeling going on. There's a lot of, we have satellite data, and we have ground-based data, but we don't have in situ data. And here's where I think we can really start to understand Earth's atmosphere, start to understand climate change, start to understand the processes. And again, what's interesting, I had this on one of the slides, is we can do this in a spatial and temporal way where vehicle or vehicles are in multiple locations. So we can start to measure atmosphere in Northern Hemisphere, Southern Hemisphere, polar regions, and really put this information together to get a really global view of what's going on.
So we had a few questions here about pricing. I know you had a number or two on some of your charts. And of course, it really depends on the application and the vehicle. Sometimes what's important is price per pound or price per kilogram. Sometimes what matters is, yeah, but how much does the whole flight cost and so forth. And so any additional information you can share on your, at least your target price ranges for different kinds of things, both for the Mark II and the Mark III?
Yeah, so for the Mark II, we haven't gotten to Mark III yet in terms of pricing, because yeah, that's going to be a whole other plan, because we're going to be launching things, small sats. That I think I failed to mention that the Mark III can launch 250 kilograms into orbit. So that we haven't priced yet. We would like people to do a flight campaign, especially on the technology development, especially on the research side of things. So a flight campaign being an entire week with daily flights. So that would be in the neighborhood of $500,000. So roughly about $100,000 per flight. So what we estimate right now.
Excellent. Can I ask you to just sit back and reflect a minute based on what you were doing, what was learned from X-Core? Any particular things that you see being applied now that we've been able to learn from over time? This is a very unique vehicle, but gosh, we're learning things from all different kinds of vehicles. It seems like you're proceeding in a pretty rapid clip in the progress you're making. So any observations on what's been learned from the past and what your secret is to advancing so quickly?
Well, there's a number of things. What comes up first and foremost here in terms of us being able to advance quickly is location, because we, as I mentioned, I mean, students started in Delft in the Netherlands and started looking for launch sites, locations where they could operate and fly the spaceplane. One of the founders' brothers was in New Zealand and had worked with the Civil Aviation Authority there and worked helicopters in that respect, and said, why don't you come over here, because we could do it faster and we could do it easier. And so half the company went to New Zealand, half stayed in the Netherlands. And we started working with the Civil Aviation Authority over in New Zealand. And there, as you may know, I mean, this was a whole novel idea for CAA, where they said, well, you know, we don't have anything like this. So let's start talking. Let's figure out how to do this. And so we've been working with them all the way through the process of what we need and coming back to us of what they felt like we could do. And then just kind of going back and forth. So in that respect, certification, well, I don't want to say it was easy, but it was pretty rapid, fairly rapid. It still took a while. It was still a process. So that was one aspect. The other aspect, and kind of the difference when you look at, say, the X-Core model versus the Dawn model. We started with a concept, a vehicle concept, and have stuck to that vehicle idea. So you see from the images, Mark III is not much different in terms of the way it looks to the Mark II. So the idea, instead of looking at, I mean, X-Core's small scale was the Easy Rocket, and then the X-Racer, which if you look at from an airplane perspective, totally different vehicles. So here we have the same vehicle. We just have iterations on that vehicle and on that, you know, on that airframe, on the systems, on that whole process. So that's how we've done it differently. The other thing is where we were similar in the sense was we took the X-Core idea of flying the vehicle, flying a plane with a jet engine on it, and then replacing the jet with the rocket engine. So that was one of the things that has retained. But yeah, I would say those two aspects are probably the two main differences. The CAA certification, flying in New Zealand, and then just the design and the progression and roadmap of that design.
Could you say a little bit about the current plan for using the propulsion system? I'm assuming under a normal flight, you'd take off with the rocket engine, and then you're coasting up to altitude and then maybe gliding back for a landing, but can you restart the engine, and what flexibility do you have for things like that?
Yeah, so we can do start the engine in monoprop mode. So it's where hydrogen peroxide as the oxidizer, HTP, and kerosene as the fuel. So we start it in in monoprop mode, and we can do that, take off on the runway under monoprop, then switch to biprop as we're lifting off, as we're ascending. And then, yeah, whatever that altitude is, 100 kilometers, I mean, we'll have a main engine cutoff point, and then continue, energy will carry us upward, and then shut the engines off, and then do this glide back landing. For the high performance vehicle, we'll have reaction control systems, so we'll be able to control the vehicle as we're up a bit higher. So, and again, kind of, it's re-entry of a sort. I mean, obviously it's not, re-entry from orbit. So there's but it's going to be pretty, I guess, a mild re-entry in that respect. So we'll be able to just come back and do a glide landing, and that's also where we could do a kind of whatever the customer wants in terms of a flight profile. So we don't have to go parabolic and go up and then come back down. We could go up and then do circles, or do loops and glide back to the runway. We do have a downrange capability, and on this vehicle, it'll be about 180 kilometers. Right now, we're limited only in the sense that we have a civilian radio. So civilian radio will get us to 60 kilometers downrange. So if we had, some higher ranging radio, we could certainly do a longer downrange.
Okay. What do you see as some of the biggest challenges that the company is facing at this point?
Growth, just, the growing pains. We're a company of over 100 people, and we've moved pretty rapidly in terms of from when we started until now. So that's that's a challenge. That's I think going to be that's a good challenge though. And I need to say that there's others, but off the top of my head, I really can't think of anything, because we're progressing well. We would like to be moving faster. We would like to say, be able to fly the Mk-II high performance in the fall, New Zealand spring, but we're not there yet. So it just, time, I think, is also a challenge, because in this industry, everybody likes to think that they can do things quickly with a little bit of money, and what we're seeing is takes a lot longer, takes a lot more money. So, and I think that goes across the board. It not only with startups, but with the larger companies as well. So I think that's sort of a general challenge within the industry.
Sounds good. So time is hard to predict ahead of time, how quickly you can advance and so forth, that if things continue to go well. Do you have at least a tentative notion as to when there might be other operating locations, such as in the US, for example, or is it too soon to say?
I would, yeah, I mean, we are looking at, again, all goes well. and we have the first flights in New Zealand at say the end of next year, 2024. So early 2025 is when we would like to have it in other locations. And it could be the same vehicle, could be a different vehicle. I mean, it really just depends on, somebody comes to us and says, we want one, and we want one here, and let's talk, because we'll start building that. But let us get to qualification of the full performance vehicle, the full commercial vehicle first, and then we can look to that. So
clearly, you need to focus on vehicle development and doing that safely and successfully. But I am positive there is already and will be even a greater interest from spaceports in the U.S. and in other locations. If people think this might be something that would fit their vision for their community, their spaceport, their ecosystem, what do they do? How can they sign up or have further discussions with you or others about doing things in the future?
Oh, yeah. Well, let's see. I had, actually, when you all get this this presentation, the last slide is my contact information. So it's a QR code. You'll get everything. So you can just send me an email, and we'll go from there. But yeah, I would like to discuss, certainly how we can enhance the local community, enhance the spaceport development, the economic development of the area, and how we can suit the needs for education, for Earth monitoring, technology development. So
that sounds great. So I know there will be a lot of people who are interested, and we will certainly make your contact information available. In the meantime, feel free to reach out to GSA if there's interest, and we can make sure you get connected with Khaki and her folks at Dawn. So this has been a fantastic presentation. Thank you so much, Khaki, for sharing the exciting developments with us, and we would love to see you part of the team in the future as we talk about the continued growth of the global space economy. So thanks again, and we'll turn it back over to James for closing comments.
Well, thank you so much, Khaki. That was really a wonderful presentation. Just for everyone's knowledge, Steve, George, and I are working on the next part of the webinar series. So check your emails on a regular basis. We'll be coming out with it in the next couple of weeks. Remember what I said at the start, Commercial Space Week is in Orlando, Florida, starting January 29th with our summit. So make sure you get that on your agenda. Thank you all for your time today, and that ends our presentation. Thank you so much. Bye-bye.